webcast is now starting. All attendees are in listen-only mode.
Hello, everybody. Thank you for joining us today. This is actually our first ever, I think, hands-on Hackin cast. So we are really excited about that today.
Everybody, just wanted to welcome Matt and Steve to Banter here. This is not the actual webcast. This is pre-show. We show up early because you show up early. You show up early, so we show up early. It's a vicious cycle, but everybody wins, right? So Matt and Steve, thanks so much for being with us today. Steve, I've not had the pleasure of meeting you. I've known Matt for years and years, and we connected on LinkedIn again here, I don't know, several months ago. And I'm like, we must have Matt. We must have Matt.
He's pretty awesome.
Here we are. So welcome, Steve. Welcome, Matt.
Thank you.
Wow, it's turning into the opposite of a roast right now. I sort of like this. You guys can keep talking positive things all day long if you want to.
We like it.
You just don't see the other channel that we're talking about you on.
I'm going to stay on this one.
So Steve, where are you located?
In Columbia, Maryland.
Columbia, Maryland.
Nice.
Very nice.
We're neighbors-ish.
Ish.
I'm in Virginia.
Ish. So, hey, Matt, I'm really excited. We got your training class up on the website on wildwesthackinfest.com. Do you want to talk a little bit about your upcoming training class and kind of what to expect?
Yeah. So, first I would say I'm excited to offer it in a better format, I would say, first to begin with, of having it in 4-hour time chunks, right? So, we've been teaching control system cybersecurity now for 10 years, and the format is one that I'm encouraged by being able to offer, so people can have someday, half at work, half while they're actually being able to then be in class and go through the content. And, so what does it mean when you then get into this class? Well, one of the things, as you've seen, even that you're going to see today with this cast, is we're all about immersion and hands-on, right? And so we're talking about cyber physical, and it's sort of hard for you to do cyber physical without some kind of a physical kit that you're interacting with. And so we supply, every registered participant with a traffic light model. A lot of people are used to thinking through traffic lights, maybe red lights, maybe green lights, maybe only green lights. I don't know. It depends if you're colorblind. Maybe it's going to be really hard then as you get into it. But the whole point, maybe you're only thinking about the outputs, right, of the lights and not necessarily the inputs and the logic. And so we use it as the model to then start thinking about all the other critical infrastructure, whether it's the electric grid, that we're aware of now a lot more. I mean, a lot of people are like, oh my gosh, right, this utility now, if it goes away, I have incredible problems to, whether it's freshwater, wastewater systems. And so we have a whole variety of things that we'll cover, and we're going to be doing an introduction today on the basis, for that course of building and breaking and securing control systems.
Well, we're super excited about it, Matt. We're excited to have you be part of this. As I said earlier, I've known Matt for a lot of years. Matt was a former SANS instructor, and that's where actually he and I met. So when I had the chance to nab him and get him over here, it's like, yep, well, this is a good thing. So super excited about it. It is a 32-hour class. So we're doing it in 2 parts, right? We're doing it in, first of all, we're doing 4 hours a day for 4 days, and then you'll have a week break, and then you'll come back and do another 16 hours, 4 hours a day. For 4 days. So it's kind of a unique training for us, but one I think that's going to be really popular, and we're really excited about it. And of course, we'd love to have it come back, after the first run again. So
yeah. Well, and I think as we all know, and I know I had the questions when I came on earlier on John's SOC course, was how approachable is OT security or Internet of Things security, of this whole cyber physical realm. I mean, that's what we're discussing here, is where cyber and the physical worlds meet. And the reality is it's very approachable, right? And I think it'll even be easier to digest in this type of format. So you have a little bit longer time to think through it, and then a break, and then you reset and you're like, I was thinking about this. And I get that all the time by students in past classes. They're just like, I couldn't get this out of my head. And, I fell asleep thinking about it. And first I was like, well, I'm sorry, sort of that you got stuck that way in it. But at least this gives you a lot more time to think through, well, hey, now I'm struggling, or I'm excited about this. I've gone back to my employer and they've identified things that they want help with, and we can guide with it and match it up with the content. And so, I'm really excited about offering it in the format. I think it's going to be that much more approachable content. Steve doesn't necessarily toot his own horn well enough, I think, sometimes with some of his background. But what he is awesome at, and then what IntelliGenesis is awesome at, is what led us to really join forces, is that big data concept. And when you think about cyber physical, your data isn't somebody filling in some kind of a username field on a web form. It's some sensor, right, that's out there, or some kind of output that you're controlling. And the number of sensors, the number of outputs has grown in magnitude. I mean, how many sensors do you have on your phone, right? You have over 60 sensors on the modern cell phones, today, and that's just one device. And then you start going further into the HVAC in your house, or the HVAC in a building, or the smart meter on your house, or the substation meters that are there. And it's so amazing what's out there, and how do you aggregate that and make any type of actual awareness of whether it's an environmental failure, that's taking place, a mean time between failure that's happening on just the equipment itself, or something else more nefarious, right? Something else more interesting, where somebody is trying to cause these things in these environments. And what the wizard here, I see Steve is, taking some of that data and analyzing it in that way. And that's what I'm really encouraged about with our relationship. The challenge, as you'll see, and I get, everybody that's here now, get super excited. I got a lot of things that I'm going to be physically showing, some hands-on things, as well as some of the demonstration we're going to have inside of the virtual machine. And that's the whole challenge around this type of training is although I know some people might like to have a power plant in their house, generally it's going to be a very small footprint version. It's not going to be the real one, the critical one. So we don't have duplicate systems, right? We don't have duplicate yachts. Although again, I would love a duplicate yacht, somehow, come my way. We don't have a spare car in our garage that we can just trash. Well, maybe a few of you do. I know some of you are very hands-on, and you want to do that, and you do tinker. But it's trying to create a representative model, support that, and make that be widely accessible. And so we're working down that path. And I would encourage you to look again at the IntelliGenesis site, the Cyber Physical Data Center that we're working on there. That was another big linchpin of us joining forces to allow something like that to happen. I also saw a shout out to DePaul come out there. Yeah, I've done a lot of teaching and working with students there at DePaul for over 20 years. So the DePaul Blue Team is up in Chicago.
Well, very cool. Very, very cool. So we're glad to have you. Thanks for joining this webcast.
Very good. All right. So we're going to have a little bit of lecture overview, and then we're going to get into going through the virtual machine, and then also having some physical things that I'm going to be showing and demonstrating. OT, operational technology, Internet of Things, all these cyber physical things, it's far from being your typical rodeo. I thought that was a good play on words as you get into it. And it was sort of interesting. I found an actual Arduino hat that was from IO Rodeo Incorporated. So I thought that was pretty cool when you got into it. But what are we talking about here with this OT space? What does that actually even mean? Well, we have inputs, and we have outputs, and then we have some kind of data and logic that's managed between those two elements, between the inputs and the outputs. Now, what kind of inputs could you have, right, in these environments? Well, we could have inputs being big pressure sensors. We could have inputs that are just simple push buttons, right? So literally, this is a snap circuits kit that you can get for your kids or for yourself. I actually love snap circuits, but there's lots of different inputs that we can have in these environments. In your car, you have an input that's an accelerator. You have an input that is all the buttons on your steering wheel. You have inputs associated with rolling up and rolling down the windows. And then we get to the output side of the equation, right? So on the output side, we have the motor that raises the window or lowers the window, or we have that pump that pumps the water, let's say, into your house if you happen to live in a rural community like I do, right? So now I have my own water pump versus the pump that's being provided by a municipality water supply in that environment. Now, you wouldn't be using this little IO rodeo hat in those environments. You'd be using something else like a programmable logic controller to be able to do something like that. This is actually a Micrologic's 1400 controller. So, and I see a few of the questions coming in. If you're going to try to download the VM right now, you probably won't have enough time to get it to be able to go through the demonstration. So I'd recommend that you just watch if you haven't downloaded it already and if you're ready to go through it. So what's also pretty amazing in the OT space is generally an OT, these Internet of Things type systems are critical by default. They are what make the business. If they didn't exist, then the business probably wouldn't exist. You know, it's how we manufacture cookies, it's how we manufacture everything that's in a store today, it's how we manage the electric grid, it's how we get freshwater, wastewater, it's how your car operates, a plane operates, a train operates, you name it, natural gas systems. So it's critical by default. And so then it serves as this essential utility for modern life. So then why does this matter as a defender? Well, it matters because the whole world changes if we don't have these things secured correctly. And so what does that mean? System breaks can cause loss of life. Well, let me just go ahead and just show you what I'm discussing here. What does that actually mean by a system break? Well, it means all of a sudden you don't have any water any longer coming in, to your house. Or it means just the alternative, you have too much water, right? All of a sudden things just become overpressurized in an environment. A pipeline ruptures or something in your house ruptures. Maybe it's tainted water that you run into. I mean, luckily, right? And again, it didn't look like it was necessarily any type of a. Well, it's hard to say who the adversary was. We'll just leave it at that. But it didn't impact the residential community when that lie was over added into the municipal water supply within that Florida community. But it shows what could happen, potentially tainting water or no water going out at all, right? Again, that's a whole other thing, right? Freshwater, wastewater. What if all of a sudden the wastewater quits flowing away? That would also be really bad. I see here in Houston, that actually happened a few years ago with some of the hurricanes that happened where the actual sewer system became flooded to the point, but that was because of a natural disaster that led to that. When there's no electricity or a surge of electricity or a manipulated waveform of electricity, the reason I included those words of waveform is where in this space, it really requires you to have not necessarily an engineering background, but to be coupled up with an engineering mindset. I highly encourage, if you don't happen to have one, getting your own snap circuits kits, just so you can understand a little bit about resistors and inputs and outputs and relays, just from these simple kits that are out there for kids. Of course, they say when you buy them, they're for ages 8 to 88, so you can go do the whole thing. But what I'm showing here is actually a relay. This is an electromagnetic relay that we can turn on and off these lights, and we can actually control this relay by energizing it and changing the flow of electricity. Now, this is a manual push button to be able to control that. This exact same relay that we're dealing with, excuse me about that, this exact same relay that we're dealing with here, let me go ahead and take a look at what that looks like if we were to associate that to a computer. So these are the relays that we connect up directly to a Raspberry Pi board. Thank you. On the camera I was pointing to. That's funny. The Raspberry Pi here is connected to our relay board that we have here. And these pins are then controlling our solar panel, or sensing from our solar panel that we have here. Now, where this was used, this was actually part of the DOE CyberForce competition, Department of Energy CyberForce competition. That is an annual competition that we've used some of the CybatiWorks platform in for the past several years. And what we're doing was actually showing hacking and defending a solar panel in the environment. So let me go and show the other camera picture that we have here, since I was showing it to the wrong camera. You called me out. Well done. So we have our snap circuit relay in place, and we have the red light being illuminated. And then when I press and energize this relay, that electromagnet is then energized, and it's causing the circuit to be completed going the other direction, then becoming a green LED being energized versus the red LED. This type of electromagnet that's changing the circuitry of how this operates is exactly like what we have here. So let me go ahead and stop sharing my screen so that I can go ahead and increase this video size. And when we take a look, these relays here are the exact same thing as the relay that we have right here, except that it is now computer controlled by this Raspberry Pi right here. That's where the world changed. That is why cyber physical systems all of a sudden became critical, is because we moved from physical control like that over to electronic control using something like a Raspberry Pi. Here's another example of some equipment. This is a Raspberry Pi. And now we have all these individual relays connected to it that we can then screw in on these terminals. Now I want to show you, look up there at the top, we can then see this normally open, normally closed condition that we have on each one of those individual relays. You go back to the snap circuit model right here, same thing, a little relay that's here showing whether it's normally open or normally closed conditions. Of course, our red light is illuminated at this point in time. This is how things used to be automated decades ago using physical push buttons or mechanical relays. And now we've moved them over to being automated again using technology, not necessarily like the Raspberry Pi, but it can be in your own houses as time continues. Now, what are some other things I just want to show you on the water pump model? So this is actually another model that we had for the Department of Energy Cyberforce competition. This is going to connect up with a virtual machine that we're going to be stepping through. But this is a solenoid valve. So this solenoid valve is controlled by electricity energizing and de-energizing to open and close this valve. Be a pretty nice add-on to your shower so that you can very easily just have it be computer controlled, right? Versus having it being controlled by you manually adjusting your shower valve. You have to set the temperature automatically. The question is, how secured is your network, your infrastructure, to make sure that this is going to operate correctly as soon as you start allowing that type of remote control in that environment, using, again, a Raspberry Pi or the programmable logic controller that I showed earlier. So when we think about these different types of equipment that we're trying to manage in these environments, let me go back to that slide that we had earlier. What are some of the things that could break? Well, what could break is maybe manipulating those relays in a way that cause them to physically destroy themselves. Possibly manipulating them in a way that causes electricity to no longer be a sine wave, or causing two different sine waves to connect to each other simultaneously that are out of wave. So if you had a little bit of electrical engineering background, you would know that that's a really bad situation. Or starting and stopping things that have inertia. So let's say your HVAC system that you have. Other things that can break are awareness. An operator with no control or an operator watching their systems being controlled. Both of those are horrible. Those are both breaks. I don't have control, or I'm watching, like what happened down in Florida, or what happened in the Ukraine, where all of a sudden the mouse starts moving around and breakers are being tripped in that environment without any control by the operator. Maybe not having any records at all, like a black box. All of a sudden, what if you go into it and it's been erased, or has inaccurate records, maybe it doesn't have correct information, or maybe even a conveyor belt not working. So I have another example here. Let me change my camera and do it correctly. This is another form of engineering Legos. They're from Fisher Technic. I like them, but this is our CybatiWorks manufacturing model. And so we have our indicator lamp saying and finding out the current status on the conveyor belts. We have the motors operating here, and then we have actual photo sensors that are in place, photo eyes in place that can sense where something is on the supply line. Now, what is really awesome is what you have in the virtual machine that you get to work with, and we're going to work with today, is we've enabled this through software virtualization. So you're going to be able to do something similar with a conveyor belt inside of the virtual machine when we do that demonstration. So what are my guidance as we go through the virtual machine? Critical infrastructure and control systems are really hard to think through how to defend them. They're easy from the standpoint of at least getting started. They didn't used to be. It used to be really hard to get started into this space, but IoT has bridged that gap. Raspberry Pis, NVIDIA Jetsons, all sorts of things have made it easier to do things that you didn't once used to be able to do. So here's another example. This is a Raspberry Pi-based self-driving car, right? It actually uses the camera on this to be able to automatically drive. But what if somebody were to manipulate that camera feed? Then all of a sudden things may not operate correctly any longer. You know, there's so many pieces. So I'm going to go into the demonstration now and show you some of the elements of a control environment using the demonstration inside the VM versus just showing you some of the physical equipment. And then I'm going to go back and do the same thing as we continue on for the webinar. So let me go ahead and share my screen again. And the virtual machine that we had everybody download, when you get it running, and you can use this, it could be in VMware Workstation 14, 15, 16, the most recent one. This is an older version of VMware Workstation that I'm using here. The biggest thing whenever you use the VMware Workstation is make certain that you don't upgrade the virtual machine. This is a little bit of an older virtual machine as far as the base operating system. But there's been about 16,000, yeah, you heard that number right, 16,000 hours of development time built into this free software that you're getting to understand control environments. So in the download, you of course should have been given the username and password. You can just type it in, root, all lowercase, and then the password of CYBATI, all lowercase, CYBATI. Now, the virtual machine only requires 2 gigs of RAM. It expanded out to 40 gigs, right? You've seen all of these pieces as you've downloaded it, but if you haven't worked with it yet, I want to make sure that you're aware that you're prepared for that. To get started with this virtual machine, we can go into the wizards folder, and we're going to open up the black box wizard. The credentials, again, are username root, all lowercase, and password of CYBATI, CYBATI, CYBATI. I'm going to go into the black box wizard, and we're going to double click on start the black box. Start the black box. Now, I'm going to go ahead and go through this slowly, right? So remember, think quickly, but respond slowly. So starting the CybatiWorks black box environment, thanks for participating in our course. For more information, you can sign up. We're going to click OK, and then it gives you the option of whether you want to start as a beginner or start as moderate or experienced. Let's keep this simple, right? Let's just start as a beginner. We'll keep it simple. The only thing that the moderate experience does is it really hides everything from you as far as what it creates, what it sets up. Let's not do that. That's going to make this way too hard as we're going through this. What this is establishing is a full software-defined network of emulated things. So what does that mean? Well, it means we're going to build a lot of different virtualized containers of things, right? So this was designed using Linux containers, really pre-Docker container world, right? We've tried to take this type of virtualization and connect it to Docker containers and get it to work, but there's still some challenges in getting them to work connected and together. But we are able to virtualize everything at the network layer and up in the stack. So right away, you can look at this and say, well, hey, Matt, I thought this was an OT course, and all of a sudden we're seeing an IT-style network. Well, when we think about defending critical infrastructure control system, that's right, LXD, Grayson, great job. When we think about defending these critical infrastructure control systems, IT is a subset of OT, right? So without IT, OT wouldn't exist. And really, without the OT side, the IT side wouldn't exist because most companies make all their money from an operational technology aspect, right? Like Amazon, yeah, they sell things, right, on their website, but the way they make a lot of their money is their warehousing capability, right, and their shipping capability, and there's a ton of automation behind that. So when you think about what matters most, it generally is going to be the OT side of the environment that we're trying to defend against, so that the IT can actually still have a life, right, to support the rest of the supporting, the rest of the infrastructure around the OT environment. So that was just step one, building, right, actually running that wizard and building this actual black box environment and getting it all operational and running. The next step that we have in here is going through and performing the active host discovery. So the black box, I just want to share with you, you can do searches for the CybatiWorks black box directly out on the internet, and you'll find some solutions to these wizards. This was released a few years ago. As far as how these wizards work, there's still been very few people step through them, and it really hasn't been promoted a lot. So I think you're going to really enjoy going through this. But the first thing we're going to do is go through the passive, or go through the process of active host discovery. There's a big warning. Why is there a warning on doing active host discovery within OT networks? Well, number one, active scanning on these industrial networks can make everything just end very badly. If you want to create a career-limiting move in trying to defend an operational technology network, it would be to jump in and start taking a traditional IT approach and trying to understand what's there and defending it. That's exactly right. So Avery was just saying because of boom. The point is, what I was saying earlier is you can literally physically break things with a cyber means. So when that's why I wanted to say on that earlier slide around what does break actually mean? It means potentially a canal gate no longer lifting or opening. It means potentially a ship being bricked. It means your car being bricked. It means your oven being bricked as we start moving the things. So yes, InMap is where we're talking about here, is doing active scanning. We have to be incredibly cautious and generally only do it after you've sufficiently tested within a test environment. I did that. So here's InMap, non-aggressive, in this environment. And since we're in a virtualized environment, we can go and take a look to see what's happening. We can just hit scan, and this is going to scan the industrial zone of this network to see what services are running there. Now, what's really important to understand in defending anything in the IT or OT space is we can really containerize and virtualize everything. We can emulate it. We can model it. And we can model it pretty sufficiently. There's a lot of things that we can do. The other thing that's different, as you may have already seen in the OT space, is you may even get down to the chip level, right? Literally, right, the chip level in these types of devices, we may be having to think about how to defend at that level. Here's another example of a chip within the OT space, right? This is a little, I know I'm zooming in as close as I can there just for you to see it, but that's a near field communication chip that we can use for authentication. That's part of the OT space. So these systems we're discovering, we don't know what they do. You might break it. It may be a badge reader. It might be a pressure valve. It might be something that's running and driving a robotic arm or some kind of bot that's out there. So you have to have a test environment to go and analyze what's there. Now, that's what we have here is we've actually completed this scan in this environment, and we're wanting to see, right, what's up and operational and what isn't. And we can see there's several hosts that are on or still waiting for the rest of the scan. Now, one thing that's interesting, here's a question. I got a quiz for you, big quiz. What port numbers by default are scanned by InMap when you don't include port numbers? If I don't include port numbers, in an InMap scan, what port numbers do we actually scan? The top 1,000. Hashcrack, you're close. The top 1,000 ports, the top 1,000 well-known ports. There we go. We got them rolling in. In the top 1,000 well-known ports on the internet are industrial control system ports included in that category. Good answers. Answers rolling in. I'm loving it. In those top 1,000 port numbers, are industrial control system ports included? They're not. That's right. The no's are coming in. So we have to run the tools correctly for the environment. And we're talking about InMap here just as an example, but think about that for all the tools. And this is where there's the difference between IT and OT and trying to figure it out and going and defending it. It requires you just to think a little differently about the criticality, the value, the type of system, and actually how that system is used in the overall architecture. Does it matter? Right? Does this pump matter? Does this valve matter? Does this push button matter? Does this logic matter? What matters in that environment? And so I'm giving that as this example of just the awareness you have to have. Now we can go in and say what ports we want to scan. We can change it. Absolutely. Wills, you're right on money, right? Grayson, yep, DMP3 we can go after. We can put in port 20,000 or going, port 502 for Modbus. We can be specific as we do these types of scans so we can get that information. So in the essence of time, I have to shrink this down, and I'm not going to go through and change some of those options with InMap. I encourage you, as you explore this environment, that you do that. What I'm going to do now is move into the next part of the wizard and do the passive host discovery. This is where I like to start, right? When we go into an environment, we want to start analyzing it. I want to passively look at what's happening. I want to just get a lay of the land by putting in a network tap. And I saw a couple other points coming in there. Say, hey, yeah, let's go and do a network tap in the environment. The challenge is, in these network taps, where do we place the tap? Where can we get the aggregated data source? Where can we find that switch so we can get the great visualization of what's happening in this environment? And does it let us actually see the edge as well? Now, right away, what is an edge? Right? What's an edge in some of these environments? Well, an edge in some of these environments is going to be something like this pressure valve that we have that I was showing you there earlier. That's an edge device that we're thinking through, an edge sensor that we have in these environments. But still, generally establishing a passive tap allows you to get a good visualization around that environment. I really like the concept of looking at the engineering workstation switches. First, finding out where those engineering workstations actually are, right? Are they in the field truck? Are they sitting out being driven around somewhere? Are they left behind, or are they in a physically secured area, that actual network that we're looking at? So here's a tap that I'm going to create into the industrial control network into this model environment. So now I've established that tap point, and I can start looking at the traffic that's flowing around in this environment. Yes, taps are also good if they're attached to keg. That's funny. We can see inside here a lot of different protocols flowing around, and Grayson was talking about DMP3 and Modbus. Those protocols are built in here. Now you can say, how in the world do we have all these protocols running inside of this one virtual machine inside the software-defined network? Well, all the protocols, any communication protocol has been created with the library. And most of these libraries are open source for you to at least get started with them. They become closed source the more that a vendor expands upon that library with extra features, right? All of a sudden, they add extra features for how their devices work with that protocol, and those may become a closed source element. And that's where, as a defender, you have to understand these languages. And so, if I take my resume and I would show it to everybody, one of the things to have on is my second language is binary. Definitely not perfect. I probably speak it just as well as English, but I do speak 2 languages, English and binary. And on the binary aspect of this, all we're doing with the protocol is sentence structure. The protocol is the sentence structure of the binary language and how it frames things, the framing of that protocol. And so what you have to do is start reversing that. And yeah, there's OSPF in here. Actually, there's even, if I go out to the edge of this network, we go to the internet side, there's full BGP running in this network, right? We have border gateway protocol, we have full IT protocols, we have full ICS protocols, there's Allen Bradley PCC, there's Modbus, there's DNP3. All of those protocols are running live inside of this environment. In fact, there's even some scripted threat actors doing some things inside of here. So, the biggest thing I can tell you, my one greatest advice to give you on using something like a protocol analyzer like we're using here, like Wireshark, is creating good filters. And to create a good filter, one of the first things you want to try to do is just stop the capture so things aren't flying by too much, or stop the scrolling. That's another configurable option you can do to actually disable scrolling on the live capture. I'm going to go ahead and stop it. And it's to create these filters. And the greatest way to get started in creating any type of filter in Wireshark, if you haven't done this, is to expand into the individual packet itself that you want to look at, the individual frame you want to look at, and find something you want to filter on. And then you can right-click on that individual element and then apply it as a filter. And then it'll start building the filter for you. So then you can start seeing what you want to filter for and how to create these unique filters. Now, you probably aren't going to be looking anything at DNP3 length of 18. That may not be the greatest value of a search. But what I encourage you to do in filtering is identifying the traffic that you identify as a known good. Take it out of your filter. Say that you don't want to see it anymore. Say, don't show these things. And then move forward. Hey, I see Tim Yardley's online here. Yeah, he did a great job with that posting several years ago, and he's kept it up to date. So I'm an Illinois alum as well. DePaul, Illinois, worked with a lot of different schools through the DOE Cyber Force, and of course my background. So that's getting started with doing some of the filtering and establishing some of these filter rules. There are some quick filters you can do, such as if you only want to see Modbus traffic, you can just type in the filter of Modbus so you can focus just on that individual protocol. In this case, there's no Modbus live yet, but there's about to be. There's about to be Modbus live in this environment. I'm going to go ahead and close that Wireshark capture down. And what we're going to do is we're going to add in VirtualPlant. We're going to add in that software-defined model. So when we started this hacking cast, I said, hey, we don't have to have any of these physical models. We've created a software-defined version inside of this virtual machine that some of you are still trying to download, and that's fine. Again, you'll be able to get this later on. You can go through this exercise. We're going to initialize VirtualPlant. And what this is going to do is it's going to add a bottling facility inside of this software-defined network black box that we just started analyzing. And it's going to give us a conveyor belt, a nozzle that's filling each one of those bottles, right? Filling up to a certain set point, and then an HMI to go with it. That's what's on the right-hand side of my screen that just opened up, the CybatiWorks bottle filling process status. So we have the HMI view, and then we have the world view as if we were actually at this bottling facility filling these things up. Now, I'm not going to name names, right? But I do know a few years ago, a major bottler of cola, it wasn't, or soft drinks, we'll just leave it at that, just soft drinks, had a spill. And it was because their nozzles couldn't close any longer, right? The thing just flooded and it all spilled out, right, of that environment, and they had to have quite a cleanup. I have had this demonstration at DEF CON, right, before. So you're getting some elements here of a good DEF CON presentation right now as well from a few years ago where we demonstrated this bottling facility. So what I want to show you is On node 12, if you look at the very top of each one of these windows, it says what it's doing. But on node 12 is the HMI, and on node 5 is the actually bottling process. Well, if I go back to that full network map that I had before, I now have node 12 and node 5 as individual workstations in the industrial zone of this environment. Well, that's where these are running. They're actually running this process back and forth, and they're talking Modbus back and forth in this environment. In fact, if I go back and do that passive host discovery again, I'll go back a step. I'll go back to step 3 in my wizard, pick the industrial control network as my tap, even if it's a Cisco Catalyst 2900, that's fine. That'll work great. That's how I got my CCIE, was on the Catalyst 2900 back in the day. But now we can see some Modbus traffic flowing back and forth in the environment. So that's been added in because that is how the HMI, the human machine interface that the operator is using the visualization of this environment to see what's happening in the environment, is reading that current status using that protocol. Now, is that exactly what you're going to have in every industrial facility, only Modbus, or the operator workstation talking directly to that protocol? No, not necessarily. You have to explore that facility and whether it has other servers and other systems to be able to support a presentation tier, a logic tier. In this case, we're emulating the industrial controller using Python code. I'm going to give a couple tips here when I summarize this hacking cast in the future, or like a couple more slides. Things you want to know are functional logic and ladder logic and how these operate. Now, a question just came in around DHCP and OT. I love it that you saw that. There are certain protocols you should never see in an OT environment. And if you see them, you got to wonder why that just happened. Did somebody just connect in another computer or another piece of technology that did DHCP by default? And now you can respond to that in this environment. So it's all about having a proper baseline, so you can then identify those anomalies, right? Yeah, 5338, Weishan. That's my CCIE number. All right. Continuing on. You have these little numbers. It's just like November 2007. That was my conversion date of going Mac from Windows. You have these little points in time that you just sort of remember. My cyber physical born on date was in 2006, right? There was a year there. So, there's just a variety of little things that have happened. So we have VirtualPlant running. Would you like to be able to take a look to see how this thing is operating? There's a great engineering document here of how this bottling facility is actually working. Now, the question would be, was the bottling facility created based upon the document, or did this magazine go in and inventory, this bottling facility, and then write about it? And then all of a sudden, the adversary got a hold of this, and they're like, well, hey, now maybe I know how to go and attack it, because they may have revealed a little too much information in this specific article, where it even includes some of the details around the screw terminals of the individual push buttons for the process and how it's operating. But this is that conveyor belt, right? This is the actual conveyor belt of a product coming in and a product going out, and it hitting a set point, using a photo eye detector to be able to say, I'm going to fill it to a certain level, and then stop and move the conveyor belt onward. So if we go back to our full bottling facility, now we can start seeing that. We can see it happen. Right? We can see that we're hitting this individual green indicator. There's a little point right here at the bottom. That's where the bottle stops. And then the red indicator is the photo eye saying that we're filling it to that point, and then the conveyor belt moves on in that environment. Now, there's some good discussions going on right now around things that have happened, right, in the grid or in different environments. I want to pause here, since we are talking about those, and show, I'm going to keep it at the small camera for right now, but to show you what it looks like, our power grid model. And we talked about DMP3. different industrial protocols are dominant in specific verticals. So you might see DMP3 for looking at the customer load, or you might see in certain regions of the world, or in certain regions, or in certain verticals. You may see DMP3 more in natural gas environments as well. Now, here we have our generating facility, our transmission lines, and then there's not really a distribution tier. It'd be over here on this far side, but then we have our customer load. And so this is where it becomes really important to understand the domain, right? The environment itself that we're trying to actively defend. Any of the questions that are coming in right now, specifically on the power grid, I do want to just show one element before I continue on, is if you look on the desktop of the CybatiWorks VM, you can click on the living textbook, and the living textbook specifically talks about things that have occurred on the build, break, and secure methodology for the power grid itself. And so I would encourage you to take a look of that specifically. All right, heading back. So where I was showing the engineering document. That's the engineering schematic number 5 in the black box wizard. And I was starting to talk about how this facility is actually architected, right? How it's actually operating. And again, in the matter of time, I'm going to cover this ladder logic that's here briefly. But what we're doing is we're examining 2 physical push buttons, and then also looking at the state of the motor. Now, this is called a sealed-in rung, here where we have the logic showing these individual examine conditions. Let's see how many engineers we have out there, or anybody that understands ladder logic, since I haven't said it yet. Is this an examine if closed or examine if open condition that we're looking for right here? We're looking for a 1. We're looking for a 1. If it's true, right, is this an examine if closed or examine if open? I'm doing a poll to see how many engineers that understand ladder logic are listening to this right now. And this is what I'm getting into is actually part of the challenge. It's part of the problem of figuring out how all these people need to be working together, right? We need to understand engineering mindset and an IT mindset together. All right, we got a lot of opens coming in. We're looking for a 1. No idea. I'm not an engineer. No worries. All right, I'm going to leave it. I'm going to leave it as a little cliffhanger for right now. But what we're doing is we're going to say whether we have a 1 or a 0 here, and this has to be going from the left-hand rung to the right-hand rung. And if we get a true condition going from left to right, it will then engage the motor, right? And then what will happen is once the motor is engaged, the only thing that's going to disengage it is if the push button number 2 is then engaged, will then break or disengage, actually, will then break this circuit going across here. I saw the comment on started as a double E. You know what? So here's where we're at. All of these control systems that we're trying to defend, they're all algorithms. They're all mathematical equations. They're all y equal mx plus b. They're all sitting there, but the actual variables are sensors. And the answer, the output, is some kind of an actuator. And what we have to defend as defenders is figuring out what that algorithm is and what the critical parts of that algorithm. I mean, I've actually had mathematicians in my courses where they're just trying to figure out how this stuff is operating and what is the critical element. Yeah, I hear you. Winner. So ladder logic, you got it. This is ladder logic that we're looking at. We have examine if open, examine if closed type conditions. Between these 2 right here, we have an examine. And an examine if open condition is looking for a 0, and examine if closed condition is looking for a 1. But if it's a true, closing the circuit being a 1 in that actual location. So that's our logic that we're running. What if the adversary got a hold of that? If the adversary actually got a hold of that information, all of a sudden now they can start doing attacks. And so what I'm going to do is jump all the way to step number 7 here. I encourage you to take this virtual machine, take these steps, and do something like I'm going to show you here. Right-click on any of these scripts that I have, go down to Properties, and see the scripts that we're running, right? Take a look at these shell scripts that we're running inside here. This is one that's a compiled one, but you'll see the actual original source code there as well. And so you can, it's just bash scripting. So all we're doing is some bash scripting to be able to get all this to work. But what we're going to do in this attack is we're going to do something called an override. So I saw a few things flying across there, something called crash override. Crash override, really the interesting part of that is an adversary took a point, they had the logic of how math was supposed to be working it, and they said, no, we're going to make it do this, and I don't care what the math says. The math says that that valve is supposed to be closed, the logic says it's supposed to be closed, but I'm going to get into the engineering front end and I'm going to override that point. I'm going to take the developer tools and I'm going to override it and I'm going to force it to stay open where it should have been closed in the first place. All of the source is inside of the VM. There's nowhere else right now. So I'm going to click that move and fill. And now you get a very good view of what could happen in this environment right away. Now, when I demonstrated this more publicly for the first time, it was sort of funny. I had somebody run over to me and said, oh my gosh, Matt, thank goodness. You just helped me give the firepower necessary to show leadership how we bottle things at our facility is critical and why our actual control system needs to be defended. Because you could do just something like this. So again, just right-clicking on each one of these, and then you can find the folders that this is running inside of, and then you can see the actual source code. And that's true for everything. There's a lot in here. As I said, there's about 16,000 hours of dev work just in this software alone. So that's the attack. The question is, how do you go and defend against this, right? How do you stop these types of attack, in these environments? And it's really to take the time to know what's normal, right? It's the baseline. And this exercise was designed in a way to allow you to see what the environment looks like before VirtualPlant was added. Productivity is way up right now. At least they're making a lot of product. It's just not getting captured at this point in time. But having a good baseline, because what we're doing right now is not part of that baseline, right? At least it shouldn't be. At least it shouldn't be part of the baseline. And that's part of whenever you start capturing or doing an analysis, then you may very easily capture an adversary that's inside of it. Yeah. So there's a question on how do we build the attack script. Each one of these scripts, and so I had said to do this, but I'll just show you. We can go into properties, we can do a copy, and then we can go to the terminal line, and we can go directly to that folder. And we can take a look at these scripts. And the attack script is just a bash script, but then the attacks themselves are all written in Python, right? So these attacks are all written in Python. Now, moving forward, what are some other ways that you can start looking and defending these different types of environments? On the back, or another thing I'm going to show you is Node-RED, right? Another really neat flow tool that you can use using the Raspberry Pi on the platform there. But not just Raspberry Pi. Node-RED runs on Mac, runs on Windows, runs on Ubuntu, runs everywhere, right? It's a pretty amazing, easy visual flow tool. And it talks a lot of different industrial protocols. So there's some neat things you can do with it. We used it to be able to architect this year's Cyberforce competition that included a wind turbine as part of the element for it. So you start going through and navigating. You can then see even how the black box was architected in allowing it to create the Ethernet IP server, to create the Allen, so the Allen Bradley PCC server, to create a DMP3 client and server, to create a Modbus client and server is inside there as well. So Network Miner is in here as a great tool. So if you were to go into shortcuts, you can then see some of the other tools that are inside here where you can use Network Miner to be able to extract data out of the PCAP and start analyzing it. I encourage you to really start exploring the platform to see what's in there. The other thing I wanted to really share, part of this exercise of learning about control system environments and some of the vulnerabilities and defenses, was to go through the CybatiWorks search engine. So, a lot of you have commented, or a couple of you commented on some of the challenges of downloading a virtual machine and some of the size of it. Well, the size is there very intentionally, where now if I want to go and learn about a given topic, so let's say the Ukraine event, I could just go into the search engine inside of the virtual machine and learn about the Ukrainian event. I don't have to go and jump out and try to get lost in searches, out on Google. I just go look there, right? And so, or if you want to learn about Stuxnet, there's plenty of articles, just on Stuxnet inside of here, Stuxnet under a microscope, or to kill a centrifuge. A lot of really good information to take a look at. A question came in of using the Metasploit Modbus client to read the unit ID and start modifying the data. You could. That would definitely be something you can do. I will tell you, though, that the Python library, when you look at it from the command line, you may find that it's easier to do it there, because that Modbus module is so easy to understand. Modbus is one of the easiest protocols to first digest. I recommend you start there. And then after that, DMP3. And then after that would be a more proprietary protocol like Allen Bradley PCC inside of Ethernet IP for some of the communication protocols. So that's how I would start that process of looking at protocols. It's definitely, I will tell you, one thing that helped me was my CCIE background, getting into networking, looking at weird protocols. I used to work at the National Lab as well. And so, looking at high performance computing protocols, MPitch, so there's all these weird protocols that are out there that people have created to do some kind of function. And it's just, how do you get started? So Modbus first, DMP3 second, and then getting into a proprietary protocol like Allen Bradley PCC. And know that you don't have to go and get any other equipment. It's all inside this VM, right? So just go into the industrial zone, look at the protocols there, and start looking at what's available. So let me jump back here. Right now, we're still being attacked, right? So we still have our plant is being attacked. Now, to stop the attack isn't necessarily easy to see from the wizards. So I just want to show this to you. You literally just go in and say execute logic attack. And then, just one moment here. I think I still had a pop-up right in the back. And once you select execute logic attack, you hit cancel. And then that'll stop that attack in that environment. So Allen Bradley, PCC inside of Ethernet IP. Another question came in, there are some other labs available inside here. Of course, we in our full class, we offer several more, but if you go into the wizards folder, so I want to cover this before we wrap up for today's Hacking Cast. There are a lot of great content just inside the Wizards directory. So if you want to see what I presented at DEF CON 25 and 26, you can go straight to this folder here and see it. So the actual workshop content is inside of the DEF CON 25 folder, but you can also go to the DEF CON 26 folder. And here, if you go into ICS 101, it actually includes the slides and the audio. The slides and the audio. Yeah, so resetting the wizards is another way. You just reset the whole thing. So if you go back, that's one of the things that we've tried to do with this wizard to make it easy. You just stop the black box, reset it, done. And you're right back to where everything was before, pristine, and you can go play around, make changes, whatever you want to. I mean, just to show you a couple more things, if you haven't used the Naval Research Laboratory core software, which is what this is, you can double click on each one of these hosts and you can get a command prompt on a per host basis. If I right click on a router and go to the shell window, VTY shell, it drops me into a terminal prompt that's running Quagga, right? So Quagga is the Cisco emulator, basically, routing, switching emulator that's available for you. But that's all running inside the black box. So if you want to understand a little bit about networking, you understand a little about some command line switches that you can do, if you want to be able to see the data flows like we were showing with Wireshark, there's all sorts of things that are in here And then if you want to reverse engineer the black box, there's all sorts of things you can look at inside that scripts folder when I was trying to show how to reverse the attack script that was there. So the last thing I wanted to show, again, was the wizards directory, the ability to see DEF CON 26, and be able to then take a look at a pre-recorded video of some additional information that will help you go through and look at the VirtualPlant exercise. All right, I'm going to jump out of here and go back to the final slide. So the goal right there was getting into emulating it. There's a question, are any Moxas present? I actually have a Moxa right over there, a Moxa wireless access point. It's a really good piece of hardware to learn about firmware vulnerabilities, because I have about 10 different versions of firmware over the past several years that show vulnerabilities of concatenation, string concatenation inside the username field, and the login credentials, the ability to escape out and not even do a login at all, because some of the original screens didn't require logins. You could just go straight to the function. That's not just their problem. There's been a lot of different problems with a lot of different hardwares, but those are things you have to look for with any type of platform of being able to jump straight to it. So I wanted to show you emulating it. I also wanted to show you seeing it. So we did that. Let me just summarize up here what some Balderdash, right? You know, basically, I wanted to say cyber-physical is hard to learn. Balderdash. No, it's not. Roll back 15 years ago, I'd say yeah. But we didn't have models. We didn't have virtual machines like this. We didn't have ways to create the protocols. We didn't have IoT. We didn't have these things. And so now, yeah, it's so much simpler than what it was. You can get a Raspberry Pi, you can start building. Get a Raspberry Pi, get Node-RED, get physical hardware, you know, that you can start connecting to it to have sensors and actuators, inputs and outputs. Electrical engineering is hard to learn. Well, yeah, it was, and it can be, right? You know, my background was industrial engineering, but then came snap circuits and taking apart toys. I'm still in the taking apart toys category. I love taking things apart. Pretty amazing the chips you get out of it. So, I encourage you when you get into it, if you want to really begin, go and buy a cell phone at Best Buy and begin with the outside of the box forward. Go to the outside of the box, get the FCC identifier, and then figure out the hardware that's in, the chips that are there, and then start delving into looking at security risks. The adversary is smarter than us. Nope, they never have been, they never will be, but they definitely want us to think it. You know, with all the social media and the things that they push, and the things that they want us to believe, they want us to think that, but no way, never going to let that happen. Active defense and inventing requires you to understand everything. I hope not, or I wouldn't be here, right? So I'm now the Chief Executive Inventor at IntelliGenesis. I'm hoping that you're going down the path of not only defending these systems, but also thinking about how to invent new things. We all have our part, and we just got to find what yours is and, and join the team. We need a lot of people to defend these things. And so hopefully you now know a little bit more about control systems, a lot more about critical infrastructure and its role that it plays in our modern life. And hopefully you're encouraged also to want to go and figure out how to defend these things. I'm going to take any questions that we have in the last few minutes if you have something specific. Are we able to get an updated VM at some point in time? So right now, the version of the VM that's out there is going to be the most recent one, except for the one that we're going to have with our course. So in our course, we'll be having an updated virtual machine that we offer inside of it. If you are interested in the course, you can then go to the, it's on the Wild West Hacking Fest. It's pinned. It's pinned in the upper right. It's pinned. It's actually pinned already as a class for you to go and reach it. If you want to learn more about ladder logic, do a search for ladder logic inside of the virtual machine. In that search engine, there's some good guidance to at least get started. It's better the more you program with it to be able to get understood. All right.
Matt, thank you. Oh, I can turn on my my camera.
Yeah.
Thank you so much again for coming on and being part of this Hacking Cast. Great information. I'm seeing some really great comments in the Discord, and somebody made the comment, whoever invented the lab was a genius or something to that effect. I believe that's you. So
it's been my passion. Yeah, it was me.
right.
I saw one question earlier just about the Raspberry Pi. We do work with the Raspberry Pi 4, right, as well. You can get up to 8 gigs of RAM on it. And it's just, there's the NVIDIA Jetson, we work with it as well. There's so many Internet of Things devices that are out there that'll expose physical inputs and outputs that we didn't have before. So there's great tools.
Outstanding. Well, great information here, and we really appreciate you being on, Matt. If you are interested in learning more about Matt's upcoming training with us, you can go to our website at wildwesthackinfest.com. It is on the training schedule along with all the rest of our training classes. So, we're excited. We're really excited about this. Great topic and definitely something that we've had a lot of requests for.
Great.
So,
Thank you.
awesome.
Thanks for everybody for participating.
Awesome. And
by the way, I'm sorry. By the way, I'll be sending you a Wild West Hackin' Fest coin.
Oh, yeah. That's awesome. Cool. Thank you.
thank you everyone for attending today, and we will see you in the next one. All right.
I'm here. Oh, sorry. I was just going to say I'm here, but I never know when Ryan's recording, so I'm going to turn my thing off now. Bye.